2024 AIME mock test problems. Here we have 15 problems. We will be considering 32 important background ideas of AIME from past papers of AIME, similar the ideas, because the ideas are repeated every year. Okay, AIME, AMC, PMO, and these are the ideas. 32 ideas. So, and here the problems are these. Let me show you the problems. The problems are these: problem 1, 2, 3, 4. For example, we had for 3 variables this problem in AIME, some of them in PMO and different national exams. Problem 6, 7, 8, 9, 10, 11, 12, and let me copy 13. Okay, so problem 13, 14, 15. Okay, if you want to have PDF of these problems, feel free to send message to my WhatsApp number in the description. Also, we will be solving all problems from 1 to, let me tell you, 1 to 10. Okay, for 11 to 15, I will tell you some hints, some of them last answers. If you want to know full solutions, again, full solutions of problem 11, 12, 13, 14, or 15, feel free to send message my WhatsApp number in the description. Okay. 2024 AIME mock test problems. Problem 1. Find the number of ordered pairs of positive integers m and n such that m cubed times n squared equals 24 to the 24. For this problem, we should apply prime factorization. Okay, idea 1, prime factorization. Okay, so here we know m cubed times n squared equals 24 to the 24. 24 is 8 times 3, or 2 cubed times 3 to the 24. So it will be 2 to the 72 times 3 to the 24. Now, because right hand side, the primes are what? 2 and 3. So for m and n, the primes should be only 2 and 3. So we can say m is 2x1 times 3x2, or let's write 2x1, 3y1. And for n, let's consider it is 2x2 times 3y2. So if we replace, we can conclude 2x1, 3y1 cubed times 2x2 times 3y2 squared. This one is equal to 2 times 3x1 plus 2x2. 3x1 plus 2x2 times 3y1 plus 2y2. 3y1 plus 2y2. It is equal to what? 2 to the 72 times 3 to the 24. By considering this equation, what can we conclude? Power of 2's are equal, power of 3's are equal. So first equation we can conclude 3x1 plus 2x2 is equal to 72. Next equation, power of 3's are equal. 3y1 plus 2y2 is equal to 24. 3y1 plus 2y2 is equal to 24. Now, here we know what? We know it is even. So this one has to be even, okay? Because if you take all things to one side, to right side, that side is even. So x1 should be even. Okay, so we can say x1 is 2x prime 1. This part is multiple of 3. This part is multiple of 3. We can call it idea 2. Idea 2 is this one. When all terms are multiple of something, for example, you say a1 plus a2, a3 to am is equal to b1 plus b2 to bn. And now suppose, for example, x divides a1, x divides a3, x divides am, x divides b1, x divides b2, x divides bn. X divides all of them except one of them. Then we can conclude x divides also a2, because you can take all terms except a2 to right hand side. Right hand side is multiple of x. So a2 is multiple of x. So here again we can say same thing. Multiple of 3, multiple of 3, all terms are multiple of 3 except this. So 2x2 is multiple of 3, so we can say x2 is multiple of 3. Again, why we can say this? We called it Euclid's lemma. Okay, idea 3. Euclid's lemma says what? It's an obvious lemma. That if A divides BC and GCD of A and B is 1, then we can conclude what divides what? A divides C. So 3 divides this, because 3 divides this, but by idea 2. Because 3 and 2 are relatively prime, by Euclid's lemma, we can say 3 divides x2. So x2 is 3x2 prime. Then, if we replace 3x1, if we replace x1 with 2x1 prime, will be 6x1 prime. 2x2, if we replace x2 with 3x2 prime, it will be 6x2 prime is equal to 72. If we divide both sides by 6, x1 prime plus x2 prime is equal to 12. Now, we know x1, x2 are at least 0. Okay, x1, x2, y1, y2, all of them are at least 0. So, here, the answers are what? 0, 12, 1, 11. When x1, x2 are at least 0, then we can say x prime 1, x prime 2 is also at least 0. So 12, 0. Because, for example, if x prime be negative 1, x1 will be negative. So how many answers are there in this case? 13 answers, 0 to 12. Similarly, we can solve second equation with same approach. Let's see, it is what? This one is even, this one is even, multiple of 2. So this one is multiple of 2, so y1 is multiple of 2 by Euclid's lemma. So y1 is what? Is 2y1 prime. Multiple of 3, multiple of 3. One term is left, so this one is multiple of 3, so y2 is multiple of 3, 3y2 prime. So we can say what? If we replace y1 with 2y prime, it will be what? 6y1 prime plus y2 with 3y2 prime, 6y2 prime is equal to 24. Now, if you divide both sides by 6, y1 prime plus y2 prime is equal to 4. Again, y1 prime, y2 prime are at least 0 because y1, y2 are at least 0. So 0, 4, 1, 3, 2, 2, 3, 1, 4, 0. So how many answers? 5 answers. We should add these two cases or we should multiply. Look, because each of these 13 cases can come with 5 cases. Okay, so each of them with each of them. So you should multiply these two numbers. 13 times 5, which is 65. So our answer for this problem is 65. If you want to learn more ideas in number theory, it was combination of number theory and combinatorics. If you want, there are lots of problems in AMC, AIME like this. It is similar to one AIME problem. If you want to learn those ideas, feel free to send message to my WhatsApp number in the description. Problem 2. It is similar to one AIME problem, but in that one we had only b minus j. Here we have absolute value. Here in that problem, I think it was 1 to 10, here 1 to 100. Okay, so gen random, we can concept b minus j, absolute value of b minus j, b times j, all these things. Gen randomly chooses a number j from 1 to 100. Bella then randomly chooses a number b from 1 to 100, distinct from j. It is important, it says distinct. And the value of b minus j is at least 10 with a probability that can be expressed in the form m over n, where m and n are relatively prime positive integers. Find m plus n is what? Okay, let's solve this one in a new page. Problem 2. Okay. So let me maximize it. So what should we do for solving this problem in first step? We can say at first, can you tell me total number of cases is equal to what? total number of cases is equal to, for B, how many cases are there? 100. Because it says for J it should be distinct, 99. Okay, so it is for J. So we're right, we don't multiply because at the end we want to calculate probability and we should divide. Okay, when you want to divide at the end, don't need to calculate completely. Now we want to calculate number of favorable cases or number of good cases. Okay, so for here it says absolute value of B minus J is what? Because for both of them, J and B are from 1 to 100, and it's not important that we select B first or J first. In both cases, the answer will be same. So I calculate only B minus J is at least 10. And when B minus J is at least 10, they are distinct, okay? Because if they are equal, B minus J will be 0. I calculate this one, and then I multiply it by 2, okay? Because also J minus B at least 10 will be same. So let's write the numbers here. J is what? 1, 2, 3, to 100, okay? Now, minimum B that we should select because J is at least 1, B we should start with 11, okay? 11, 12, 13 to 100. Now, uh, for B1 we cannot reach any good case, B minus J at least 1, 2, 11. For 10, for 11, 11 and 1, 11 minus 1 is 10, so 1 good case. For 12, 12 1 is good, 12 2 is good. So how many good cases? 2 cases. For 13, how many good cases are there? 3. For 100, how many good cases are there? 90. Okay, from 1 to 90. So it will be 2 times 1, 2 to 90. So for this one, there are some identities you should memorize. Here, 1 to n is so much obvious. You should know it is what? You should know 1 squared to n squared is what? You should memorize it was also in AMC 10, 12 useful. 1 cubed, 2 cubed to n cubed was what? 1 plus r to r to the, for example, n is what? If absolute value of r is less than 1, 1 plus r to infinity is what? Telescoping rule like this, you should know this. And van der Waals identity, hockey stick identity, I know problems of AIME that can be solved with this special case of van der Waals identity. We had exactly this in AIME 2021 or 2020. 2020, I think probably 2021. It was a problem related to subsets. In that problem, you should use this. And hockey stick identity again in recent years useful. If you want to know other identities that are important for AIME and other exams, as I said before, feel free to send message to my WhatsApp number in the description. Now we want to calculate the probability. It is equal to 2. By identity, the first identity, this one is what is n times n plus 1 over 2. Because we have multiplied by 2, so let's write it's 2 times 90 times 91 over 2 by the formula. We can cancel 2, so it will be 90 times 91. Now, if you divide, it will be 90 times 91 over 100 times 99. So you can cancel this, 11, so it will be 91 over 101. We cannot divide anymore because 91 is multiple of 7 and 13. The denominator is not multiple of 7 or 13. And sorry, when we multiply 11 by 10, it will be 110. So in the simplest form, 91 and 110 are relatively prime, so m is 91, n is 110, so answer, which is m plus n, is equal to what? Is equal to 201. Okay. Again, as I said, if you have question, you can send message. Problem 3. Find the number of 7 tuples of positive integers a, b, c, d, e, f, g that satisfies the following system of equations. So we have this, and you should find for each problem, if your answer was greater than equal 1000, you should find remainder of your answer when divided by 1000. Okay. So try beat this problem on your own, and let me tell you the ideas that we should use for this problem. We should use, let me add a page. So for this part, A, B, C, D, these variables, they have a common variable. It is what? It is D. So one idea, let me tell you, it will be which idea? Idea 5. Idea 5 is consider the priority is to start with the case that start from the most restricted or limited case. Okay, restricted case. Here it is what? Here it is D. So D can be what? First, again, like idea 1, we should prime factorize. A, B, C, D is equal to 72. 72 prime factorization is what? It is 8 times 9. So it is 2 cubed times 3 squared. D, E, F, G is what? It is 21 times 10. So for 10, we have 2, 21, 3, 5, 7. If you prime factorize 2 times 5, 10, 3 times 7, 21. Okay. Now, because we should consider, we should use casework again, and in casework most of the time, but sometimes without casework, you should consider the most restricted case first. So here we should apply casework, and we prime factorize. What are the cases of D? D can be what numbers? D can be 1 or 2. Can D be 5? No, because here we don't have 5. It can be until the GCD of them. 2, 3, and 6. Okay, which 2 or 2 times 3? We have these cases. Now let's calculate each case together. But before that, you should know stars and bars is what. Okay. Let me explain for you stars and bars is what, and the thing we need here, idea 7. Stars and bars. So suppose, for example, someone tells x1 plus x2 plus x3 is equal to 20. Okay. You say how many stars are there? 1, 2, 3, 4, 5, 2, 20 stars. Okay. 3 to 20. And I can say before that, probably you know permutation with repetition is what, but let me tell you that before to make sure you know the idea or not. Permutation with repetition. Okay, so suppose for example we want to see A, B, 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 C has how many permutations? You say 1, 2, 3, 4, 5, 6, 6 factorial, because we have two A's, 2 factorial, 3 factorial. Or you can say 6 choose 2 for placing 2 A's, then 4 choose 3 for B's, and 1 choose 1. You can ignore 1 choose 1. Or you can say first, let's place B's, 6 choose 3, then 3 choose 2 for A's, and 1 choose 1 for C. All of these things, okay? It is the idea for permutation with repetition. Now, in next step, we can say what we want to solve this equation. We say we have 20 bars and we want to split them into 3 parts for x1, x2, x3. So, how many dividers or bars do we need? 2. This one will be for x1, this one will be x2, this one will be x3. Each answer for x1, x2, x3 corresponds to one permutation of these two bars and 20 stars. So it will be by permutation with repetition. 22 factorial over 2 factorial, 20 factorial, or 20 choose 2. Now we want to generalize this idea, okay? If instead of x1, x2, x3, We have x1, x2 to xk. What can we say? x1 plus x2 to xk is equal to n. How many stars are there? Let me write stars with red. 1, 2, 3, 2, n, like 20. How many dividers or bars are there? 1, 2, 2, k minus 1. Because for 3 we had 2 dividers. It's split into 3 parts. For k minus 1, k variables, we need k dividers. Why? Because it's x1, x2. Last one will be xk. So how many permutations are there? We can say n plus k minus 1 factorial objects. We have n plus k minus 1. N factorial k minus 1 factorial. So we can say it is equal to n plus k minus 1, choose n, or n plus k minus 1, choose k minus 1. We have around 4 more important ideas in the stars and bars. How to solve when they are greater than equal something, less than or equal something, when the whole part, in whole part we have inequality, something like this. If you want to learn all those ideas that are useful, as I said before, feel free to send message to my WhatsApp number in the description. Okay, let's solve these cases. If D is 1, let's see what happens. Case 1, D is 1. So A, B, C then will be what? We can replace D with 1 in first equation. It will be 2 cubed times 3 squared. For next equation, D, E, F is equal to 2 times 3 times 5 times 7. Okay. Now for ABC, I will explain for you one of them, for example, how to, because 2 is not related to 3. Here, 2 not related to 3, not 5, not 7. So if I tell you, for example, in how many cases can we create 2 cubed, the rest will be similar, okay? So let's focus on only 2 cube and then we can solve the rest like this. For this part, we can say, okay, A is 2x1 times something. B is 2x2 times something. C is 2x3 times something. And when we multiply, we know in ABC we have 2 to the x1 plus x2 plus x3 times something, which is equal to 2 cubed times 3 squared. And then we can say x1 plus x2 plus x3 is equal to 3. And then x1, x2, x3 are at least 0. Okay, like previous problem. One condition here. Xi are at least 0, and again here xi are at least 0. Then, for example, if xi be at least 1, two dividers cannot be in same place. And we cannot calculate all permutations like this, and the answer will be smaller than. So here xi are at least 0. If we use our formulas, again, we have 3 stars, 2 dividers, and we can use this formula, n plus k minus 1. You can say here n3 plus this, 3 plus 3 minus 1. Choose 3 or choose 2. Which is 5 choose 3 or 5 choose 2. Okay. Now for this case, the answer will be what? 5 choose 2 for 3. For 2, if we calculate like this, it will be 4 choose 2. Here the powers are 1, and you should multiply, because for each case of these 2 we can select each case of these 3, each case of these 2, and so on. Because it is 1, as you can see, when 3, 3 plus 2, because we have 3 variables, 3 plus 3 minus 1, which is 3 plus 2, 2 plus 2. Again, here we have 3 variables. So 1 plus 2 is what? 3. 3 choose 2. 3 choose 2. 3 choose 2 for this one, and 3 choose 2 for this one. Okay, so let's calculate. 5 choose 2 is 10. 4 choose 2 is 6. 3, 3, 3, 3, 3 to the 4 is 81. This one is 60. If we multiply, it's 0, 6, 4, 80. Okay, 400, 4,806. Now, let's consider second case. For second case, D is what? These two. Cases of D are these. Now we want to calculate these. So if we replace D with 2 here, ABC will be what? You can cancel 2 from both sides. So it will be 2 squared times 3 squared. For this one, if you replace d with 2 is what? You can divide both sides by 2. So EFG is what? It's 3 times 5 times 7. And then how many cases order do we have here? 4 choose 2. Again, let's write both of them in one row. For 2, 4 choose 2. Similarly, for 2, 4 choose 2. For these ones, 3 choose 2. 3 choose 2. 3 choose 2. So it will be 4 choose 2. 4 choose 2. 6 times 6 times 3, which is 27. 6 times 27, 6 times 7, 42. We have 4, 6 times 2, 12 plus 4, 16. 6 times 2 again, 12, we have 1. 6 times 6, 36 plus 1, 37. We have 3. 6 times 1, 6 plus 3, 9. So in this case, the answer is 972. Now let's calculate third case. In third case, D is 3. Okay, and you can see for this one, because the powers here are different, we should calculate. ABC is what? If you replace D with here, D with 3 and divide both sides by 3, it will be 2 cubed times 3. And then EFG, if you cancel 3 here, it will be 2 times 5 times 7. So again, if you calculate, for 3, it will be 5 choose 2. For 1, it will be 3 choose 2 here. Because all powers are 1, then it will be 3 choose 2 times 3 choose 2 times 3 choose 2. 5 choose 2 is 10. 3, 3, 3, 3. 3 to the 4 is 81, 810. One case is left, last case. In last case, D is what? D is 6. So if I replace D6 here and divide both sides by 6, ABC will be what? Will be 2 squared times 3 to the 1. And for EFG will be what? EFG, it will be 5 times 7. So again, it will be 4 choose 2 for this power. Next one, 3 choose 2, 3 choose 2, 3 choose 2. It will be 6 times 3 cubed. 6 times 27. 6 times 7, 42. We have 4. 6 times 2, 12 plus 4, 16. 162. Now let's add all these numbers. This number, this number, this number, and this number. 2 plus 2, 4. 6 plus 1, 7, 7, 14, and 6, 20. You have 2. 2 plus 1, 3. 3 plus 8, 11. Plus 9, 20. Plus 8, 28. We have 2. 2 plus 4 is 6. So, our answer is 6,804. In the beginning of the video, I said if the answer is greater than or equal 1,000, consider mod 1,000. So the answer will be what, like problems of AIME. It's 804. Okay, so we solved this problem and we've considered how many ideas so far? 8 ideas. Okay, it was problem 3. Now let's focus on problem 4. Problem 4, how many real numbers satisfy the equation this? We have these two terms, and as you can see, this part is equal to this part. Okay. So let's solve it in a new page. So let me add, sorry, it's 3. Okay, let's try 4. How many real numbers satisfy the equation this? So here, as you can see, this part is equal to this part. The bases are equal. And we know that if AB is equal to AC, then what are the cases? We want to divide both sides by A to the C, so A shouldn't be 0. So one case A is 0, in second case A is not 0. If A is not 0, we can divide both sides, for example, by A to the C. Okay, then it will be A to the B minus C is 1. Now for this part, we have three cases. So A0, let's write 2, 1. A is 0, but B minus C shouldn't be 0 because 0 to the 0 is undefined, shouldn't be 0. Case 2, 2. A is 1. Case 2, 3. A is negative 1 and the power, what can we say about power? Probably you say that power should be even. Yes, but it is not general case. We can say what? Power should be even number over, for example, it can be also a fraction, 2k over 2n plus 1, which is GCD. It is in the simplest form. Means if it is a fraction, rational number, if you simplify as much as you can, it should be even over odd. So we should check these four cases, but a cannot be negative 1 here because a is what in this case? A is absolute value of x squared minus 12x plus 20. So a is at least 0 because absolute value is at least 0. So we don't need to check case 2, 3. So we have to check only case 1, case 2, 1, case 2, 2. But let me tell you something. Here, because we said a is 0, b minus c shouldn't be 0, we can say what? Do we need to check case 2, 1? Because if a is 0 here, we know that b shouldn't be 0, c also shouldn't be 0, okay? For example, it is 0 to the 5, 0 to the 5. It is okay. And this part, or let me tell you a better thing. Here, we said a is not 0, so again we shouldn't consider this case. If a is 0, b shouldn't be 0, c shouldn't be 0 here, because 0 to the 0 is undefined. So we should check case 1 and case 2, 2. Okay? So for case 1, what can we say if we want to check case 1? And one more thing. Here, maybe the power is 0, 2, 4. We can say the power is 0. So b minus c 0. And in this case, we know a is not 0. Okay, because we are in this case. So in this case means b should be equal to c. So let's try this part together. First case, a is 0. It means that absolute value of x squared minus 12x plus 20 is 0. So we can conclude x squared minus 12x plus 20 is 0. You can use quadratic formula or you can factorize x minus 2 minus 10, product is 20, sum is negative 12, 0. So x is 2 over 10. Let's check, because we said b shouldn't be 0, c shouldn't be 0. When usually when they don't write any base, it means it is log 10, okay? So when it is 10, log 10 to the base 10 is 1, minus 1, 0. So this power will be 0. So 10 is not good. For 2, this one is not 0, this one is not 0. So the product is not 0. This one is 1 minus log 2. It is not 0 because if it wants to be 0, this one should be negative 1. And it means that x should be 10 again. So x2 is our first answer that satisfies the equation. Now let's check case 2, 2. A is 1. It means that absolute value of x squared minus 12x plus 20 is 0, is 1. So we can conclude x squared minus 12x plus 20 is what? It's 1. Or plus minus 1. So we can reach two equations. First equation, x squared minus 12x plus 20 is 1, which is plus 19 is 0. Next one, x squared minus 12x plus 20 is negative 1, plus 21 is 0. So x is negative 12 plus minus square root of b squared 144 minus 4 times 1 times 19. Okay, minus 4 times 19 over 2. So if we divide, it will be negative 6 plus minus. Inside square root, we should divide by 4. 144 over 4 is 36. minus 19 is 17. Okay, so our first answer is our second answer, and second and third answers are these. And you can easily check the powers. Here the powers are not important to be 0 or not, because for A1 the powers can be anything. Now for this one, x is, sorry, negative b here, plus 12, plus 6, okay? So for next one again, 12 plus minus square root of, for this one, let me tell you, it was idea stars and bars, idea 8. For this one, let me tell you, idea 9 is what? Quadratic formula. If we have ax squared plus bx plus c is equal to 0, we are using that. Then x is equal to negative b plus minus square root of b squared minus 4ac over 2a. So if you don't know some formulas of logarithm, if you want to learn them again, as I said, you can send message my WhatsApp number. Okay, so it's 144 minus 4 times 21 over 2. So it will be 6 plus minus divided by 4. 36 minus 21, which is 7. 36 minus 21, no, 9 plus 6, 15. So 2 more answers. So 5 answers so far. Now we've checked this one. We've checked this one. One case is left. B minus C is 0. Okay? Or B is equal to 0. B equals C and A is not 0. So let's check. B is what power of here? This times this, which will be log x squared times negative 1 plus log x. This B minus C is this one. Minus 1 plus log. Let me tell you something again. You can write it as idea 10. Log 1 over x is minus log x. Because it is x to the negative 1, you can take power in front of log. So 1, let's write it. 1 minus log x. This one is equal to 0. And we know that this one shouldn't be 0. Base shouldn't be 0 because 0 to the 0 here is undefined. Okay? And it was the case that a was not 0. A was not 0. Here we can conclude x is not 2 or 10. Okay? So we know x is not 2 or 10. Now we can factor from here. We can apply, for example, this plus. It will be log x squared times negative 1 plus log x plus negative 1 plus log x is equal to 0. So we can factor from negative 1 plus log x. It will be log x squared plus 1 is equal to 0. Now let's see what can we conclude here. The first one is 0 or second one? If first one is 0, negative 1 plus log x is 0, so log x is 1 if you add 1 to both sides. So x is what? X is 10, but it's not good because we said x cannot be 2 or 10. Or log x squared plus 1 is 0, so log x squared is negative 1. And by definition of logarithm, let me tell you, idea 10, idea 11. Log b, a to the base b is m. It is equivalent that b to the m is a. So here it is 10, so it is equivalent that x squared is 10 to the negative 1, okay? So because x squared is 10 to the negative 1, what can we conclude? We can conclude that x is plus minus 1 square root of 10 to the negative 1, or 1 over 10. But because here we had x in this part, x should be positive, domain of logarithm. Let me tell you, domain of logarithm is what? When we have log b to the base a and b should be positive, b shouldn't be 1, okay? So because here we have x should be positive, so here we can only say x has to be equal to 1 over square root of 1 over 10. So how many answers do we have so far? Let me check all of them. 1 answer, 2 answers, 2 answers, 1 answer. So 6 answers. So the answer will be equal to 6. As I said, if you want to learn other and important formulas in logarithm and other topics, feel free to send message to my WhatsApp number in the description. Okay, let's try. We solve problem 4. Now problem 5. Okay, for problem 5, let me move it a bit. This part better. Yes. Okay. It says let n be the number of ways to place the integers 1 through 9 in the 9 cells of a 3 by 3 grid, so that for any 2 cells sharing a side, the difference between the numbers in those cells is not divisible by 3. Find the number of positive integer divisors of n. Okay. This problem is similar to one problem of AIME 2023, but in that problem it was the size of table 2 by 4, I think. 2 by something, 2 by 6, I think. And you should fill with 1 to 12. Here is 3 by 3. Okay. In this problem, because we should consider only divisibility, their difference between the numbers in those cells is not divisible by 3. So we should consider mod 3, all things mod 3, idea 12, idea 13. Sometimes you should consider all things, for example, here mod 3. So we have 3 zeros, 3 ones, 3 twos. Okay? So if we determine, for example, 0 be here, 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 for example, 1 here, 2 here, 2, 1. It is one good case, okay? Then, in how many ways can we place 1 to 9 in these cells to satisfy, for example, 0, 0, 0, 1, 1, 1, 2, 2, 2? In 3 factorial for zeros, 3 factorial for ones, 3 factorial for twos, okay? Because for zeros, they are what? 3, 6, 9. So in how many ways can you place 3, 6, 9 in these cells? 3 factorial, okay? So we should see in how many ways can we place 3 zeros, 3 ones, 3 twos in this table, and then at the end we should multiply by 3 factorial cube. Now I told you in previous problems that when you want to calculate something, one thing is to consider the most restricted case. Here, which cell is the most restricted one? Mid cell. It can be 0 or 1 or 2. So we multiply by 3 and place 0 because we have 3 zeros, 3 ones, 3 twos, and the problem is symmetric with respect to 0, 1, 2. And when it says the difference shouldn't be multiple of 3, it means that we don't have 2 zeros that are adjacent, 2 ones that are adjacent, 2 twos that are adjacent. So the problem is symmetric with respect to 0, 1, 2. And we can say, okay, mid cell is 0 without loss of generality, and we multiply by 3. Now, we know zeros cannot be in these cells. Okay, these cells are back. So we have 2 zeros are left. These 2 zeros should be on the corners. Okay, so they can be adjacent corners like this or opposite corners. For adjacent corners, let me paste it here. Okay, 0. Adjacent corners. For this one, we multiply by 4 because it can be here or here or here or here. For opposite, we should multiply by what? This opposite, this opposite. We should multiply by 2. Okay, now, in this case, again, we should say, okay, the most limited cell is what? This cell is adjacent to this one and this one. Let's consider this, and it is symmetric. So it can be 1 or 2. It cannot be 0. So we say that let's multiply by 2 and place 1 because the problem is symmetric with 1 and 2, and this cell is symmetric with the zeros that we placed. So 1. Here it should be 2, 2 because we have only 1 and 2. Adjacent cells shouldn't be equal. This one should be 1. What? Because we have 2 here, should be 1 here, 2, 1. So we have 3 ones, 2 twos. So this one has to be 2. Okay, so this one was 4 times 2, 8, plus this one. Here I say this cell can be 1 or 2. So we multiply by 2 and we place 1 here. So this one has to be 2. Now here we have 2 ones, 1, 2. Because we have 2 ones, this cell is adjacent to both of them. Okay, so it should be, because of 2 ones are left, 2 ones and 2. So it will be what? It will be 4. So now we can say it's what? N is what? N is this. So we can say N is 3 times 8 plus 4, 12 times 3 factorial 6 cubed. So 3 times 12, 36. times 6 cubed. 36 is 6 squared. 6 squared times 6 cubed. So it will be what? It will be 6 to the 5. And if we prime factorize, it will be 2 to the 5 times 3 to the 5. Now, number of positive integer divisors of n is 5 plus 1. The formula is this. So let me tell you something. We have formulas for number of positive divisors. Also, you should memorize sum of positive divisors and product of positive divisors. You should know the formulas for these things. And also, for example, one problem that is good, a hard problem, one problem of Promise 2022. It's a summer camp problems of prestigious summer camp. We have a hard problem in Promise 2022 that improves your problem solving for divisors. So 5 plus 1, 5 plus 1. Why we say 5 plus 1? Because the power of 2 can be 0 to 5. So 6 cases, 36. So the answer of this problem is 36. Okay, for problem 6 in cyclic pentagon ABCDE, ABD is 90, BC is CD, AE is parallel to BC, AB is 8, BD is 6, so Pythagorean theorem we can say this one is 10. AE squared can be expressed in the form m over n. Now, where m and n are relatively prime positive integers, find m plus. Okay. Here, let's see what are the conditions that we have. For this problem, as I said, there are around 40-50 important ideas in geometry. One of them that is so much useful is that, for example, if you have a triangle ABC, and if you connect O to R, then we can say what? We can say, okay, it is O. It is lies on perpendicular bisector C. And because it is inscribed angle, it is a central angle, it is 2A, so this one is A, it is R. And you can say sine A is equal to this length is A over 2, because M is midpoint. Is A over 2 over sine A. Sorry, A over 2 over R. And if you rearrange this, R is A over 2 sine A, okay? This is an important formula. So we can say what here? We can say because it is 90, it is 10, so R is what? R is half of that, 5. And as you can see here, you can write also this as A is equal to 2R sine A. Sine A is what? If you have a circle like this arc is 2A, so half of this arc, okay? Arc BC is 2A because of inscribed angle, this A. 2R sine half of it. Now, let's consider, for example, this one 2 beta, okay? We want to relate chords to angles. This one, for example, 2 alpha, 2 alpha. This angle is what? At the end, we want to find AE. So, because this is parallel to this one, when we have two parallel lines, like this and this, these two arcs are equal. The reason is what? Because if we connect this one to this one, then we can say it is alpha because they are parallel. It is alpha alpha, so the arcs, this one is 2 alpha, this one is 2 alpha. It is idea 8. So because these two lines are parallel from assumption of the problem, 2 beta is equal to this one. Let me write 2 beta is equal to 2 alpha plus DE. Arc DE. So arc DE will be what then? 2 beta minus 2 alpha. So let's write 2 beta minus 2 alpha. And this one will be what? Because the whole part is 180, so it will be 180 minus 2 beta plus 2 alpha. Okay. So now let's see what can we say. For 8, you can use this formula. you can say 8 is equal to r, because 2r is 10, r is 5, is 10, times sine half of this arc. We said BCD is sine A. So this arc is what? Is 2 beta, so sine beta. So we can conclude sine beta is equal to 8 over 10 or 4 over 5. It is our first good result. Now we want to find something in terms of alpha. We use 6. 6 is equal to 10 sine 4 alpha divided by 2 alpha. So sine 2 alpha is 6 over 10 or 3 over 5. So second good result. Now I want to find AE. I know AE is 10 times sine 180 minus 2 beta plus 2 alpha. It is equal to 10 sine 2 beta. Let me check. 2 beta plus 2 alpha. Okay. Here we said this. Okay. 2 beta minus 2 alpha. When sum of two angles equal to 180, their sines are equal. Now, here we want to see, can we find beta in terms of alpha? We can find, because here their sum is 180 in this semicircle. So we know that 2 beta plus 4 alpha is 180. Okay. So 2 beta is equal to 80 minus 4 alpha. So it will be 10 sine 180 minus 4 alpha minus 2 alpha. Okay. So, sorry. Here we should divide this by 2, okay? Because we said half of that r. So, let's divide that. It is 90 minus beta plus alpha. Now we can say what? So, let's calculate it again. Here it is 90 minus beta plus alpha. From here we know beta is, if you divide by 2, 90 minus 12. So it will be 10 sine 90 minus beta, which will be minus 90 plus 2 alpha plus alpha. This one will be cancelled, 3 alpha. So it will be 10 times sine 3 alpha. I told you until idea 18, idea 19. Idea 19 is what? Sine alpha plus beta is sine alpha. There are around 10 formulas in trigonometry. If you want to learn them, feel free to send message to my WhatsApp number in the description comments. Okay. So here we can say it is equal to 10 sine alpha plus 2 alpha. So it is equal to 10 times sine alpha cosine 2 alpha plus cosine alpha sine 2 alpha. Okay. Now, we know beta, the relationship between beta and alpha. Beta is this. So here we can say sine beta is 90 minus 2 alpha. Sine 90 minus 2 alpha is cosine 2 alpha. Okay. So cosine 2 alpha is 4 over 5. So let's replace. Sine, we found cosine 2 alpha, sine 2 alpha. Okay. And they are positive. And we know 2 alpha is from 0 to 180. And now in this case, we know sine 2 alpha is what? Let me write it. Is this? Sine 2 alpha is 3 over 5. Cosine 2 alpha is what? 4 over 5. So the only thing we need is to find sine alpha and cosine alpha. Now for finding sine alpha and cosine alpha, again we should use another identity. Cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And special case of this is cosine 2 alpha is cosine squared alpha minus sine squared alpha. And we have a basic identity in trigonometric. In trigonometry is sine squared alpha plus cosine squared alpha is 1. So you can say, okay, first one, You write cosine squared alpha. Next one, 1 minus cosine squared alpha by identity 21. So it will be 2 cosine squared alpha minus 1. If we replace cosine squared alpha with 1 minus cosine squared alpha. If we replace cosine squared alpha with 1 minus sine squared alpha, it will be this. Okay? Now, we know cosine 2 alpha is what? It's 4 over 5. So let's calculate sine alpha and cosine alpha here. We can say 2 cosine squared alpha minus 1 is 4 over 5. So, here, we can say if we add 1 to both sides, it will be 1 plus 4 over 5. If we use common denominator, 5 plus 4, 9. So if you divide both sides by 2, cos squared alpha is 9 over 10. Now, if you take a square root, cos alpha is plus minus square root of 9 over 10. Now, if we consider unit circle, again, considering unit circle so much powerful, at first you should draw it, or trigonometry circle. After, for example, after solving some problems, you can imagine this. Here, the problem from this part of problem, 4 alpha is less than 180, okay? 4 alpha is less than 180, so alpha is less than 45. So we can see alpha is from here to here. This is for cosine, this is for sine. Now we know that in this part, if you consider sine is from 0 to root 2 over 2, and all cosine from root 2 over 2 to 1, both of them are positive, okay? So because of this, we can say, okay, cosine alpha is positive, the square root of 9 is 3, and over root 10, okay? It was cosine alpha. Now let's use this one to find sine alpha is what? 1 minus 2 sine squared alpha is 4 over 5. If we take this to left hand side, this to right hand side, then 1 minus 4 over 5 is 2 sine squared alpha. 1 minus 4 over 5 is 1 over 5. Is 2 sine squared alpha. So sine squared alpha is 1 over 10. So sine alpha again, because it's positive, is 1 over root 10. So sine 1 over root 10, cosine 3 over root 10. 1 over root 10, cosine will be 3 over root 10. Now, because we multiply by 5 by 10, so let's write, it will be 10 times 4. In both denominator, we have 5 root 10. So it will be 4 plus 3 times 3, 9. 4 plus 9. Now, we can divide this by both numerator and denominator by 5. And then we can say it is equal to what? 4 plus 9, 13. Okay. Now we can say it is equal to what? We can multiply both numerator and denominator by root 10. It is this over 10. If we rationalize, then we can divide by this. It is 13 root 10 over 5. It is what? It is AE. The problem wants what? Wants AE squared in the form m over n. So AE squared is 13 times 13 times 10 over 5 times 5. We can cancel this 5 is 2. So let's write it here. 13 times 13 is 169 times 2. Try to memorize squared less than 1000. 5, 2 times 9, 18. We have 1. 2 times 6, 12 plus 1, 13. We have 1. 2 times 1, 2 plus 1, 3 over 5. So answer will be what? This m over n in the simplest form. So m plus n is 338 plus 5, which is 343. It is our answer. Okay. We've considered 21 22 ideas here. If you want to learn more, as I said before, feel free to send message to my WhatsApp number in the description. It was problem 6. Okay, now let's try problem 7. Problem 7, let ABC be real numbers such that these 3 equations are satisfied. Suppose the only possible values for the product ABC are these things, And r over st over u are both fractions in lowest term. Find r plus s plus t plus u. For this problem, we want to use replacement. Also, this idea is useful in many problems of AIME. We had also in AIME 2023. It will be idea 23. So idea 23 is what is replacement. Now I want to calculate C in terms of A first here. We can say 3CA is 4A minus 2. So if you divide both sides by 3A, it will be 4A minus 2 over 3A. Okay, so now from first one we can calculate B in terms of A. So we can say 2 is equal to 6B. If we take these to right hand side, minus 3AB, so it will be B times 6 minus 3A. So we can say B is equal to 2 over 6 minus 3A. Okay, so we found B in terms of A and also C in terms of A. And now we can replace B and C with these two terms in second equation. So let's write 3B. So instead of B, we write 2 over 6 minus 3A. C, 4A minus 2 over 3A. Plus 2 is equal to 5 times C. C is this one. 5 times 4A minus 2 over 3A. Now, here we can cancel 3 from both numerator and denominator. It will be 2 minus A. And then I want to get rid of denominator, so I multiply by 2 minus A times 3A. Okay, so left hand side will be what? It will be 2 times 4A minus 2 plus 2 times 2 minus A times 3A is equal to 5 times 4A minus 2. 3A will be cancelled times 2 minus A. Okay, now it is a quadratic equation in terms of A, and we can find A. Then we can find B and C by these two things, and then we can find the product. Okay, product ABC. Here, if we multiply, it will be what? 8A minus 4. Then, this part is what? 6A minus 3A squared. If we multiply by 2, it will be 12 minus 6A squared. Now, this part is what? Okay, so on right hand side, if we multiply, it will be negative 4A squared. 4A times 2, 8A minus 2 minus A, 2A plus 8A, 10A. And minus 2 times 2, which will be what? Which will be negative 4. Okay. But here we can do something. It is multiple of, let's divide by 2 first. Okay. Let's simplify a bit more. We can divide both sides by 2. 2, 1. So this part will be what? Minus 2A squared and 4A minus 4A plus A plus 5A minus 2. Okay, so we can also divide this by 2, so it will be what? It will be 4A minus 2 plus 6A minus 3A squared is equal to negative 2A squared, and we should multiply it by 5, so it will be negative 5 times this negative 10A squared plus 25A minus 10. Now if we take all things to left hand side, 10A squared minus 3A squared will be 7A squared. 4A, 6A, 10A, negative 25, negative 15A, minus 2, 10 minus 2, which will be 8, is equal to 0. Now, we should use quadratic formula. A will be negative, negative 15, 15 plus minus square root of 15 squared, which is 225 minus 4AC, 4 times 8, 32. 32 times 7, 7 times 2, 14, 7 times 3, 21, plus 1, 22. Okay. Now we should divide it by 2 times 7, 14. So it will be 15 plus minus 1 over 14, which will be which will be what? 16 over 14 and 14 over 14. And we can say it is equal to 8 over 7 and 1. Okay? Now for each of them, we should find A, B, C. So for first case, A is 1. For second case, A is 8 over 7. And now we want to find then B, and then we want to find C, then we want to find A, B, C. So let's copy the formulas of B and C in terms of A. B is what? 2 over 6 minus 3, which is 3. So it's 2 over 3. If we replace A with 1 here, it's 4 minus 2, 2 over 3. Okay, this is our first case. If it is 8 over 7, we can say in this case B is what? B is 2 over 6 minus 3 times this, which is 24 over 7. Now if you multiply both numerator and denominator by 7, it will be 14. 42 minus 24. We can divide both numerator and denominator by 2. It's 21 minus 12. So it will be 7 over 9. Okay, so let's write 7 over 9 and see. 4a minus 2. 4 times this a, 8 over 7 is 32 over 7. Minus 2, 3a is 24 over 7. Now, if you multiply both numerator and denominator by 7, it will be this over 24. This one, 16, 18 over 27. If you simplify, divide both numerator and denominator by 9, it will be 2 over 3. Okay? Now, let's check it again. Sorry. It was 24. So let me correct this. 24. 32 minus 16, 18 over 24. We can divide both numerator and denominator by 6, so it will be 3 over 4. Now, if you multiply A, B, C, here 2, 2, 4, 4 over 9. This one, 8 over 7 times 7 over 9 times 3 over 4. 7, 7 will be cancelled. This one 3, this one 2, so it will be 2 over 3. Okay? 2 over 3, 4 over 9. The problem wants what? The problem says, okay, the fractions, for example, first one, R over S, next one, T over U in lowest terms. Find R plus S plus T plus U. R is what? 4 plus 9 plus 2 plus 3. 4 plus 9, 13. 13 plus 2, 6, 15. 15 plus 3, 18. So the answer is 18. We had one problem in AIME that could be solved with 2023. In that problem, we had similar equations. I think it was in AIME too. We had 3 equations, 3 variables. But because in that case, the equations were similar, you could solve with subtraction also. When we have similar equations, we can do addition or subtraction. Here, in that problem, we could solve it also with replacement. So replacement is so much powerful in these types of problems. Okay, it was problem 7. Now, let's try problem 8 from number theory. It says find the number of pairs of positive integers nk that satisfy the equation n plus 1 to the k minus 1 is equal to n factorial. Okay, for this problem, we can use small examples, okay? Here it says find the number of pairs of positive integers nk that satisfy the equation this, okay? Now one thing, here it is n plus 1, here it is n factorial, okay? So we can say what? We can say n plus 1 to the k is equal to n factorial plus 1. For example, let's check n1. It will be 2 to the k is equal to 1 factorial plus 1, which is 2. So k is what? K is 1. K is, yes, 2 to the 1, k is 1. So one answer, let's write, for first answer, it is 1 and 1. It is our first answer. Now let's check n2. So it will be 3 to the k is equal to 2 factorial plus 1. Again, 3. So k is 1. So next answer is what? N is 2, K is 1. Now let's check N3. If we check N3, it will be 4 to the K is equal to 3 factorial plus 1. 6 plus 1, 7. It doesn't work. If we check N4, it will be 5 to the K is equal to 5 factorial plus 1, which is 1, 2, 5 factorial. Let me check 4 factorial, sorry. 4 factorial plus 1, which is 25. And we can say, okay, it's 5 squared, so K is 2. So 4, 2. We found third answer. N is 4, K is 2. Let's check N5. For N5, 6 to the K is 5 factorial plus 1. Now here we can consider something. It's not possible because this one is even. 5 factorial is also even. So even plus 1 odd, it's not possible. If we check N6, we can say, okay, 7 to the K is 6 factorial plus 1, which is 721. Okay. We know 7 cubed is what? Is 49 times 7. 7 times 9, 63. And 7 times 4, 28, 343. And 7 times this, which will be greater than this. Okay. Now the idea here that we found, if these two things are multiple of a common thing, then it's a contradiction. Okay? If these two things, for example, both of them multiple of 2, it's bad because then plus 1, we don't have any good things. So GCD of this part, n plus 1 to the k and n factorial should be 1. Okay? Which is equivalent, the GCD of n plus 1 and n factorial is 1. Okay, the reason is what? Let me tell you the reason, the proof of this. Suppose it is D. We know D divides this one. D divides this one. So D divides their difference. So D divides their difference is what? 1. So because by definition of GCD, D is positive. D is a divisor of 1. So D has to be 1. Now, because this GCD is 1, we can say what? We can say n plus 1 is what? For example, n plus 1, I want to say if it is not prime, it is a composite number. Okay? And it is multiple of something below that. So from here we can conclude n plus 1 is prime. Why? For example, suppose n plus 1 is not prime, n plus 1 is 9. Then if you multiply 1 to 8, because 9 is, for example, 3 times 3, then 3 is here. Or in general, if n plus 1 is not prime, it is AB, which A and B are at least 2 and less than or equal n minus 1. Because AB equals n plus 1, we can say, okay, if it is composite number. Then 1, 2 to n, then you have A here. Okay, and that's a contradiction if it is composite number. So n plus 1 is prime. Now that n plus 1 is prime, we can say p to the k is equal to, let me write, n plus 1 to the k was what? Was n factorial plus 1. N plus 1 is a prime, is p. So we can say p to the k is equal to p minus 1 factorial plus 1. Okay? Then we can say what? We can say, okay, p minus 1 factorial is equal to p to the k minus 1. And here we want to use a famous identity. How many ideas have I told you so far? Idea 23. Idea 24. An minus bn. We have also two more identities similar to this. Here it's not useful, but in some problems they are useful. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description. So here we can say, okay, it's p minus 1, like 1 to the k, then p to the k minus 1, plus p to the k minus 2, plus p to the k minus 3, to p plus 1. Okay? And then if you divide both sides by p minus 1, then we can say p minus 2 factorial is equal to p to the k minus 1 plus p to the k minus 2 plus p to the k minus 3 to p plus 1. Okay? Here we can say, because we've checked and p is n plus 1. We've checked until n6. In this case, n plus 1 is 7. So we can say p is greater than 7. We can conclude p is at least 11. Next prime after 7 is 11. Okay. Now if we consider mod p minus 1, both sides. Left hand side is what? Because p minus 1 is at least 10. Okay, and it's not prime because p is prime. And because it is at least 10, you can write it in form such that this one equal to 0. Why? For 4, we cannot say this because for 4, if we multiply the rest, 1, 2, 3, it's not 0. This one, look, for p minus 1, for example, if p minus 1 is 4, you cannot say this. But because p minus 1 is at least 10, you can always find a good way. Why? Because p minus 1 we know is not prime because p is prime. P minus 1 is 2 times something, p minus 1 over 2. And they are not equal because p minus 1 is at least. So we can see both 2 and p minus 1 over 2 in this part. So it will be 0, mod p minus 1. This one is 1, this one 1, 1, 2, 1 plus 1. How many ones are there? K. So we can conclude k is 0 mod p minus 1. So we can say p minus 1 divides k. And then we can say, okay, k is at least p minus 1. Now, from the equation we had what? P to the k is equal to p minus 1 factorial plus 1. P to the k is at least p to the p minus 1 because we said k is at least p minus 1. And p minus 1 factorial is 1, 2, 3 to p minus 1 plus 1. We know this one is less than p, all of them less than p. So it will be less than p to the p minus 2 plus 1. And obviously it is less than p to the p minus 1 because when you multiply this by p is at least 11, we said. And here we said p is at least 11. So when you multiply by a number that is greater than 11, greater than equal 11, and this part is large, obviously it covers this plus 1. So we have this, so that's a contradiction. P to the p minus 1 is less than p to the p minus 1. So how many answers have we found so far? So we can say that P can be what? P can be, we've checked which P's. P greater than equal 11 doesn't work. 3 answers. This one was for Pn plus 1 P2. This one P3. This one Pn is 4 P5. So how many answers are there? 3 answers. So the answer will be 3. Okay. It was, I can say, number theory that the level is related to hard problems of AIME. Okay, it can be also first problem of USUM or USAJM. If you want to solve hard problems of number theory, want to learn important topics, as I said before, feel free to send message to my WhatsApp number in the description. Okay. Problem 8. Now problem 9. For problem 9, I want to tell you an idea when you have GIF that is so much useful in AMC, AIME, and other exams. Problem 9, we have this condition, and it says if we consider x and y, floor of x, integer part of x, y, big M, small m, sorry, small m is minimal. Now, so big M is maximum, small m minimum. The set of all real numbers xy such that xy are from 2 to 20, 22, and f of xy less than or equal to can be expressed as a finite union of disjoint regions in the plane. The sum of the areas of them is a over b, and a plus b is what? Okay. For solving this problem, okay, let's solve. When we have these types of problem, the idea is what? I told you idea 24, idea 25. So much useful in AIME, AMC. When you have something like this, write x as k plus r, okay? Which k is integer part, r is fractional part, and r is from 0 to 1, and k is integer, okay? Now here, I say, okay, x is, the problem says this part, the product should be at most 2. I write x is k1 plus r1 in this problem, and k2, y is k2 plus r2. And we know r1 is from 0 to 1, r2 from 0 to 1, and k1, k2 are integers because the problem says x and y are from 2 to 20, 22. We can say k1 positive integer, k2 positive integer, and at least 2. Now, if we write f of xy will be what? Without loss of generality, suppose that k2, because here we should see maximum of integer parts k1, k2. Suppose k2 is greater than or equal k1. Why I said without loss of generality? Because the problem is symmetric with respect to x and y, and it's not important to consider which of them. So f of xy is the square root of k2 times k2 plus 1 times x minus small m is k1. Okay, so x minus k1 is r1, absolute value of r1, we know it is at least 0, plus for y minus m, it is k2 plus r2 minus k1. Okay, in this case, small m is k1, minimum big M is k2. So it will be k2 minus k1 plus r2. Now, if I want to prove k2 is equal to k1, if k2 is strictly greater than k1, because they are integers, this part will be what? At least 1. The difference will be at least 1. This one, because we know k2 is greater than or equal k1 greater than or equal 2. It is at least square root of 6. So the product is at least square root of 6, but the problem says it should be less than 2. So 2 is greater than or equal root 6, you can raise to the power of 2. 4 is greater than or equal 6, which is contradiction. Or you can say root 6 is 2.4, 2 point something. So here we've reached contradiction. If k2 is greater than k1, we have this, so we can conclude k2 has to be equal to k1 has to be equal to k. Now we can say x is k plus r, y is k plus r1, y is k plus r2. Again, r1 is at least 0, 1, r2 at least 0, 1, and k is positive integer at least 2. Now, also we should pay attention to this part. K cannot be greater than 2022. So let's focus on this function, f of x and y. So f of xy will be what in this case? F of xy will be square root of k times k plus 1 times this minus k r1 plus r2. Okay, for a specific k, we have this. This one has to be at most 2. So r1 plus r2 has to be less than or equal 2 over square root of k times k plus 1. Here you can use a small examples. One important idea, 26 small examples, so much powerful. Small example. For example, check k2, k3 and see for each of them what's the region. We should calculate the area. Well, like solve it for general k. I say, okay, for general k, I know. I consider xy plane. So here it is what? R1 plus R2. It is at most this part. Suppose this variable is C, so we can say it means what? This part and this region, okay? It is C, because this sum is C, okay, for this part. Now we can say what? R1 plus R2 is at most this area. So the area in this case is what? Is C times C over 2, which is C squared over 2. C squared is what? Is 4 over k times k plus 1 over 2, which will be, if we simplify 2, 2 over k plus k times k plus 1, which is 2 over k minus 2 over k plus 1. And this k can be what? Can be from 0, can be from 2, because xy are from 2 to 2022, to 2021, because 2022, if we have, for example, 2022, we cannot consider this part because the problem says x and y should be less than or equal to 2022. So we can't have any fractional part for 2022. So we can say k is from 2 to 2021. So k from 2. And here you should use telescoping sum or rule. Idea 25, idea 26. Telescoping sum. It's useful also in AMC 8, 10, 12, AIME, IMO. Use sum or AIME. So from 2 to 2021, 2 over k minus 2 over k plus 1. So if we write for 2, it is 2 over 2 minus 2 over 3. If we write for 3, 2 over 3 minus 2 over 4. And then 2 over 2021 minus 2 over 2022. Then we can cancel like this. So it will be 2 over 2 or 1 minus 1 over this one. If we simplify this, it will be 10 over 10 11. And we can express it as something over something. A over B, it says A plus B is what? Mod 1000. A over B. A plus B is what? 2021. Okay? So, we can say if we divide it by 1000, it will be what? The answer will be last 3 digits, will be 21. So our answer is 21. Okay. It was problem 9. Also, we had similar problems in AIME in previous years, and we can solve it with similar idea if you want to learn, if you want to solve more problems, more similar problems. As I said before, send message to my WhatsApp number. Let's solve problem 10. This is the last problem we want to solve. For 11 to 15, I will tell you some hints, last answers. If you want to know the solutions of 11 to 15, feel free to send message to my WhatsApp number in the description. For problem 10, it says in triangle ABC, AB is 6 root 3, AC is this. Okay, so let's draw. Okay, problem 10. In triangle ABC, AB is 6 root 3, AC is 12 root 3. So we can say AB equals C, 6 root 3, B is 12 root 3, and S is a point on BC such that AS is the angle bisector of BAC. These two angles are equal. S, let T be the reflection of S across AB, this one, and T is this one. If AC is parallel to BT, so this one, find the length of CT squared. Okay. So, because these two triangles, we can say, let me call this one M. Let's see what can we write. Here we want to find CT squared. We can say, because these two things are parallel, this angle is, these two triangles first are congruent to each other. Can you tell me by what criteria BMT is congruent to triangle BMS? You should use angle chasing. You should find similar triangles, congruent triangles, cyclic quadrilaterals, and we have lots of important ideas, 40, 50 important ideas in geometry. And if you want to learn them, you can send message. Can you tell me by which criteria these two triangles are congruent? As you can see, this side, the common side, these two equal, and the angle 90. So two sides and angle between. And then from here, we can say, okay, this is 2 alpha. It is parallel to this one. So because we have this angle will be what? This angle will be 2 alpha. Okay, because BT is parallel to AC. Because these two triangles are congruent, you can say this one is 2 alpha. Okay. Now, in angle bisector, let me see how many ideas have I told you so far. 26. Idea 27. In my previous videos also I explained this. And it is what? Then we have angle bisector. It is A, it is B, it is C. For example, it is S. It is B, it is C. It is A over 2, A over 2. When we draw angle bisector, by angle bisector theorem, we know what? We know BS over SC is what? It's C over B. Also, you should know that BS is equal to AC over B plus C. And one of the formula that you should memorize. This one is AB over B plus C, okay? You should know all lengths when we have internal angle bisector, external angle bisector. For example, AIA is BC over S minus A cos A over 2. IA is what? And I remember in one problem of AIME it was useful. Without this one also you can solve, but these things, these formulas helps you to solve the problem faster. AIA, IA is excenter of A. AIA, BC over S, S is what? Semi-perimeter, minus A, cos A over 2. These things, lots of formulas, 40, 50 formulas. Now by this one, we can find BS is what by this formula? C is this, B is this, so we can calculate, we can say, okay, it is, let's write, at first, can we find A? Okay, let's first find BC, okay, before using this formula. This one is 2 alpha, this one is 2 alpha. So ABC is isosceles triangle and A is equal to B. So A is equal to 12 root 3. Now we can find these lengths. So it is AC. It is 12 root 3. times 6 root 3 over b plus c. B plus c is what? 12 plus 6, 18 root 18, some of them 18 root 3. So if you simplify root 3, 18, 6, 3, 3, this one 4. 4 root 3, okay? And because these two triangles are congruent, you can say, okay, this one is also 4 root 3. And if you want to find, you can find SC by the formula, or you can say A is 12 root 3, this one is 4 root 3, so BC is 8 root 3 by complement rule. Now the problem wants what? The problem wants CT squared. So in these problems, work a bit on assumption, a bit on the sentence of the problem. We can use cosine law. Again, we can say which idea? Idea 28, cosine law. And idea 29 is work a bit on assumption and start a bit on the sentence and try to reach a common point here. So, CT squared by cosine law is what? In which triangle? In triangle BCT. Cosine law. CT squared is BT squared plus A squared BC squared minus 2 times BT times A cosine 4 alpha. We know BT is what? BT is 4 root 3 squared. A is what? 12 root 3 squared minus 2 times BT. 4 root 3 times A. 12 root 3 times, let me move them, cosine 4 alpha, okay? Cosine 4 alpha. So as you can see, we need to find only cosine 4 alpha. Let's simplify. Here it is 16 times 3, 48. 144 times 3 minus 2 times 4, 8, 8 times 12, 96 times 3 times cosine 4 alpha, okay? Now we need to find cosine 4 alpha, and here we should see, can we find, for example, cosine 2 alpha or not? We can find easily cosine 2 alpha. Why? Because here, let me explain for you. With an easy way you can calculate. Because it is isosceles, if you draw this altitude, we know this one, b is equal to a. Both of them is equal to 12 root 3. And because it is isosceles, when we draw altitude, it is also median. So median is what? Here 6 root 3, so 3 root 3, 3 root 3. And this angle is what? 2 alpha. And cosine 2 alpha is what? Adjacent over hypotenuse. It is 3 root 3 over 12 root 3, which is 1 over 4. Cosine 2 alpha is 1 over 4. Now, cosine 4 alpha is equal to, we have a formula I told you in previous problem, 2 cosine squared 2 alpha minus 1. So it will be 2 times 1 over 16 minus 1, which will be 1 over 8 minus 1, which will be negative 7 over 8. Okay? Now let's replace here 48 plus 144 times 3 plus 96 times 3. Because it is minus 7 over 8, we can apply on this 7. It's 7 over 8. Now if we divide, this one will be 12. And here we have 3. All these numbers. Let's calculate. 48 plus 3 times 4, 12. We have 1. 3 times 4, 12 plus 1, 13. We have 1, so 432. Plus 12 times 3, 36. 7 times 36, 7 times 6, 42. We have 4, 7 times 3, 21 plus 4, 25. And 8 plus 2, 10 plus 2, 12. We have 1. 1 plus 5, 6. 6 plus 3, 9. 9 plus 4, 13. We have 1. 1 plus 4, 5 plus 2, 7. So the answer for this problem is 732. Okay, as I said, if you want to learn other formulas, feel free to send message to my WhatsApp number in the description. It was problem 10. For problem 11 to 15, I will tell you some hints or last answers. If you want to learn, if you want to solve them completely, if you want to know the full solutions, as I said before, you can send message to my WhatsApp number. Okay. So for problem 11, you should consider, because the degree is 3, the number of real roots can be 3 or 1. Okay, it cannot be 2. Why? Because when we have one complex number that is not real number, the conjugate is also a root. So if z is a root, always z conjugate is root also. Okay, we can use these. So we have 2 non-real roots, or 0 non-real roots, or 3 real roots and 1 real. Okay, these two cases. For this case, you should say, okay, because they are real, each root can be +1 or -1, +2 -2, +3 -3. And then you can say, suppose we have x1 from this, x2 from this, and you should solve it with stars and bars. In previous problem, I've explained. For this one, you should consider one real number and one root, two roots that are conjugate of each other, are complex, and you can solve this. We had similar to this problem in previous past papers of AIME. For problem 12, last answer is sine length of the square. If you want to have this in AIME, for example, suppose we call it a, the problem says a squared is what? Okay. And this problem, a squared, the answer will be 58. Okay, I said this because in AIME, last answers, we don't have square root. So if you have this problem in AIME, it says, okay, calculate the square of side length of the square. It is problem 12. You can try this one. Again, if you have question, you can send message to my WhatsApp number. Problem 13. For problem 13, you should say, okay, for example, because a cube number ends in this, so we can say mod 16, mod 10,000 is this. So mod 16 is 8811. You can simplify, and a cubed is 8811 mod 625. And then there are different approaches. Some approaches also are useful in past papers of AIME. You can calculate and you can reach some numbers. And let me tell you one answer for this. It is not necessarily best answer. You should check. And in my previous videos, I solved similar problem to this one in PMO. So A is, you can say, not necessarily this. One problem that, one number that satisfies this is 8371. This one cubed is something and it ends in 8811. Okay, so, and you should see its best answer or not. For problem 14, you can prove that xy can be plus minus 1 over square root of 2. So the answer for this one will be 0, the sum. Again, for this one, there are similar problems, some of them same in past papers of PMO, different Olympiad exams. Some of them I changed them. For example, the problem sometimes has similar idea, because in AIME also, if you solve some problems, you will see ideas are repeated. So ideas are important. And for problem 15, it has an important, I can say idea. It is what? You can say it is g of mn, and then here, you can write g of m, g of n, then g of m times g of n. We've created this m plus 1 g of m, so we should write m plus 1 here. M plus 1 g of n, we write m plus 1, let me write m plus 1. And then we have this times this. M plus n will be created, but we have mn and -1. Mn and 1 we should subtract. Now this one is equivalent to this one. These two are equivalent. Then you can add mn plus 1 to both sides, and now you will reach a so much good thing. As you can see, all of them have same form. Okay? And then you can define what? You can define, for example, f of x is equal to g of x plus 1. By this definition, we can conclude f of mn is equal to f of m times f of n. And now by this approach, it is so much easier to solve this problem. So I solved 1 to 10 completely. For 1 to 15, I told you some last answers, some hints. As I said before, if you want to learn important ideas, and I can say, let me tell you this. This was an idea. I can say idea let me tell you, idea 27, 28, 29. I can say this idea 30. And also you should use binomial theorem for this one, for some part 31. Reaching to this form is idea 32. Okay, for example, we have some complicated term. You try to reach something that have same pattern. Okay, we worked on these things. Probably for AIME 2, I will release another mock test, and also for other exam, probably for USAMO, USAGMO, if you want to solve these types of problem, wanted hints or anything like that, feel free to send message to my WhatsApp number in the description and comments. Okay, thanks for watching this video. Have a good day and bye.